Okay, so welcome, and now what we're going to do is we're going to do some examples, and we're going to use different identities to solve each one of these, okay? And again, so just follow along, and again, and also there's more than one way to solve some of these. I'm going to show you one of those going forward, okay? So let's see here. Let's start with this one. Okay, so here all we're going to do is just use the quotient identity here. So this just gives us what? It gives us sine theta over cosine theta times cosine theta. So the cosine thetas cancel, and so we end up with sine theta, which is the result we wanted. Now here in this second one, what we're going to do is we're going to use the fact that we could use even and odd functions to help us get to here. So here we start here, and I'm going to say, well, this is equal to, well, sine is an even, or excuse me, an odd, an odd function, right? So what's going to happen here? We're going to get this to be negative or a subtraction. So let's do that. So this is going to give us 1 plus sine theta times 1 minus sine theta. Now what we have is we have the form of 1 plus x times 1 minus x, which gives us a difference of 2 squares, right? So you should recognize that. So this is going to end up giving us 1 minus sine squared theta. And of course, this is the Pythagorean identity just manipulated. So this is going to give us cosine squared theta, which is the result we wanted. Okay, now, what about this one? Now what we're going to do is we're going to use the other Pythagorean identity, right? One of the alternative Pythagorean identities to do this, okay? So what I'm going to do is I'm going to rewrite the top because, again, notice that this is secant squared minus 1. So this is 1 over cosine squared. So this could be cosine squared over cosine squared, which leaves us over here tangent squared, okay? Because what we have is tangent squared plus 1 equals secant squared, right? So this is going to be tangent squared. So we start with that and we say tangent squared theta over secant squared theta. And then of course we could use the quotient identity here. We can write this as what? We can write this as sine squared theta over cosine squared theta divided by what? What is secant? Well, that's 1 over cosine. So we're going to write 1 over cosine squared theta. And then of course we can multiply by the reciprocal of this, right? And so that's going to equal, that's going to equal sine squared theta over cosine squared theta times cosine squared theta, and the cosines cancel and we end up with sine squared theta, which is what we wanted. Now the other way of doing this is we could split this up into 2 fractions, right? So we could write this as 2 separate fractions, and I'm going to just write it right here. So we could write this as 1, well, let me do it at intermediate step. So this would be secant squared theta over secant squared theta minus 1 over secant squared theta. So we could have done that, right? So instead of going this route, we could have just went from here to here, and then this would become 1, and this becomes what? Cosine squared theta. And then we get 1 minus cosine squared theta, and that gives us the other Pythagorean identity that we could use, which gives us sine squared theta. So that would have been an alternate way of doing it. And that would have been fine. Okay? Have a great day, and I'll see you soon.